In the last video, we were asked to approximate this integral using left endpoints. Now we are asked, using 5 subintervals and right endpoints, approximate the integral. Again, we're asked if this is an underestimate or an overestimate. So before we get into the thick of things, let's just review our definition of a right Riemann sum. Our right Riemann sum says that the integral from a to b of f of x dx is going to be equal to the limit as n approaches infinity of the sum from 1 to n of our function of x sub I, or f of x sub I, multiplied by our change in x, or delta x. Delta x is defined as b minus a over n, and x sub I is a plus I times delta x. Now, for our purposes, we are only using 5 subintervals. We are only using 5 subintervals and right endpoints. So we don't need the limit as n approaches infinity. We're just going to use all of the other parts of this. So let's see if we can figure out our a value here is going to be the same as the lower bound of the integral, which is -2, just as we had before. Our b value is going to be the same as the upper bound of our integral, which is 3. Our delta x is just going to be b minus a. It's going to be 3 minus negative a over n. Now, instead of the limit as n approaches infinity giving us infinite subintervals, we're just going to cap it at 5 subintervals. So this is, every time we see an n here, this is just going to equal a 5 because we're using 5 subintervals. So 3 minus -2, well, that's going to be the same as 3 plus 2, which is 5. And that gives us 5 over 5, which is just going to equal to 1. So our delta x, our change in x, is just equal to 1. Now, what is our x sub I going to equal? Well, that's going to equal a, which is our -2, plus I, multiplied by our change in x. Well, we already know that our change in x, or our delta x, is just 1. So I could multiply this by 1, but I think you understand that that would just equal I. And now we're ready to write our sigma form of our summation. So again, we're just going to pattern match here and just leave out the limit as n approaches infinity. So we have our summation from I. Oops. Bring this up a little bit for you there. I equals 1 to 5. So everywhere we see an n, we're just going to put a 5 there. Of f of x sub I. Well, our function is just x cubed plus 1. So the plus 1 is going to stay the same, and we're just going to put our x sub I in brackets here, and then we're just going to cube that. X sub I, we determined, is -2 plus I. -2 plus I. All of that cubed, just like we have up here in our function, plus 1. And the 1 is going to be part of our summation. I just didn't want to draw everything in brackets because I wanted to keep things more streamlined and simple looking so that we don't get confused. Before we begin to evaluate this, let's just take a look at what our function is going to look like over this interval. So here we have, this is the interval from -2 to 3. And notice that I've already drawn our boundaries here, and our function is as appears in green. So we're just going to approximate this using right endpoints. So here's what this is going to look like. From -2 to -1, if we say that this is the right endpoint along that interval, well then we just have a rectangle that is completely flat. So that's going to equal 0. For the next subinterval from -1 to 0, if this is our right endpoint, well then we're going to have a rectangle equal to 1 times 1, or 1. And the reason it looks a little bit squished is because we have compressed all of the values here in our y direction, just because we go all the way up to 28 here, so we would be off the page if we kept everything to scale. When there's our origin there, between 0 and 1, if this is our right endpoint here at 1, 2, then this is going to be our rectangle. And if from 1 to 2 we have the right endpoint up here at 2, 9, at the point 2, 9, and that's going to be the rectangle. And then between 2 and 3, between x equals 2 and x equals 3, along that interval, if we have our right endpoint all the way up here, there's our right endpoint right there. I'm just going to do my best to try to draw this rectangle here. Then these are going to be what we're adding up here. So again, this was just a flat rectangle. It's just going to equal 0 area. And then we're going to be adding that rectangle plus this rectangle plus this rectangle here. And I think you can see where this is going. Clearly we are over our function here. None of these rectangles are underneath the curve, and just by clean that up a little bit here. Just by eyeballing it, you can tell that this is going to be an overestimate. But let's evaluate our summation. All right. So we are evaluating the sum from I equals 1 to 5 of -2 plus I cubed plus 1. And before we start that, let's just write this a little bit differently. A little bit of algebraic simplification here. I like to put, if we can, I like to put what's positive out front and then what's minus to the right of it. Maybe that's just me. But we could say this equals summation from I equals 1 to 5 of I minus 2 cubed plus 1. And recall that the 1 is also part of our summation. And when we expand this, we are just going to get the sum I'd like to encourage you to maybe pause the video and work this out for yourself, because these next few steps might go rather quickly. The purpose of this video is to review Riemann sums and not necessarily expanding polynomials. So if you need to go back and review some of that material, or just take a little bit more time evaluating this, go right ahead. this is going to equal I cubed minus 3 times I squared times minus 2 gets us minus 6 I squared plus 3 times I minus negative 2 squared. Well, that's just going to get us 12I. And when we have minus 2 cubed, that's just going to give us negative 8. And when we add our positive 1, that's just going to give us negative 7. So all of this we've expanded into this. Now we can distribute our summation. We can distribute our sigma notation here. We have the sum from I equals 1 to 5 of I cubed minus, pull out the 6, the sum from I equals 1 to 5 of I squared plus, pull out the 12, the sum from I equals 1 to 5 of I minus 7, that's a 7 there, of the sum from I equals 1 to 5 of 1. I could have just written times 5 here, but I didn't want to skip too many steps because I didn't want to confuse you. And let's just evaluate this. You might want to go back and review your summation formulas. Again, what we're about to do is going to go a little bit quickly. So we're just saying that 5 is in. So I know that the summation of I cubed is going to be n times n plus 1 over 2, all of that squared. And when we evaluate this for n equals 5, that gets us 5 times 5 plus 1 over 2, all of that squared. Good. Minus 6. The summation of I squared is going to be n times n plus 1 times 2n plus 1 over 6. And when you evaluate that for n equals 5, we just get 5 times 5 plus 1 times 2 times 5 is just 10 plus 1. I could have written 6 and 11 here, but again I didn't want to skip too many steps because I want this to look at least a little bit familiar for you. 6, the 6's will cancel out. We will look at that in the next step. And now we're evaluating this one, so we have a plus 12. And the summation of I is just going to be, from 1 to n, is just going to be n times n plus 1 over 2, or in this case, n is 5. So that's going to be 5 times 5 plus 1 over 2. And so I'll go ahead and write this in brackets so that you know that the 12 is not in the denominator. Minus 7 times n, and again our n is 5. Alright, so let's evaluate this and see what we get. 5 times 6 is going to be 30 divided by 2 is 15. 15 squared is going to get us to 225. Here our 6's are going to cancel out, and we are left with 5 times 6, which is 30, times 11, which is 330. So don't forget our minus, and we have 330. All right. Here we have 5 times 6, which is 30, divided by 2, which is 15. 12 times 15, that gets us to That gets us to 12 times 15 is 180. And minus 7 times 5, which is 35. Now this is sort of my way of doing it. We have a positive term here, we have a positive term here. I'm just going to group these two together. And that's going to give us a positive 405. Here we have a negative term, here we have a negative term. I'm just going to group these together. And that's going to give us a minus 365. All right. 405 minus 365. This is going to get us to 40. And assuming that I haven't made a mistake anywhere, this is the evaluation of our sigma notation. Let's see if this makes sense here. So we're claiming that all of this equals 40. So sure enough, when we have this block here, which is just 0, plus this block here, which is just 1, this block here, which is equal to 2, this block here, which is equal to 9, plus this block here, which is equal to 28. 1 plus 2 is 3, plus 9 is 12, plus 28 is going to be 40. So just like that, we have shown that this integral is going to be less than 40. It's going to be less than 40. 40 is going to be an overestimate.